Now let us see a case. In this case, I am having the voltage now. This is the applied voltage and it is the polarizing quantity, therefore it is at reference. Now the current flowing through the voltage, because voltage coil is having some resistance and inductance, obviously the current flowing through the voltage coil in the directional unit will lag voltage by some degrees. So let us say the current produced or current flowing in the voltage coil is lagging by some degrees, okay, and the flux will be produced by this voltage coil, and that flux is called phi V. Understood? The flux is called as phi V. Next thing is, let us say the current is flowing in the circuit is, okay, leading the voltage by some degrees theta, because theta is the angle between voltage as well as current flowing in the current coil. Okay, simultaneously the flux produced by the current coil is also on the same angle. Let us say I am just calling as phi I. Okay, phi I is the flux produced by the current coil, phi V is the flux produced by the voltage coil, and flux produced by the voltage coil lags the applied voltage by some degrees due to the designing of the voltage coil. Understood? Now I am telling what is MTA, maximum torque angle. So maximum torque angle is that angle when the torque produced will be maximum. Now you see the torque is produced due to the interaction of two fluxes, phi V and phi I, isn't it? Phi V and phi I. So whenever two fluxes are trying to interact and produce some torque, when will the torque will be maximum? We already know that torque produced due to two fluxes phi 1 and phi 2 will be proportional to sine alpha, where alpha is the angle between the two fluxes, and if alpha or the angle between two fluxes is 90 degrees, then only torque produced will be maximum. Now tell me, what should be the angle between phi I and phi V? It should be 90 degrees. That means, as I was telling, V is a polarizing quantity. That means this phi V position is fixed. Only thing that should vary is current. Therefore, now tell me, what could be my maximum torque angle line? Maximum torque angle line should be 90 degrees with phi V. So I am drawing a maximum torque angle line or MTA line. So this is the MTA line, maximum torque angle line. Understood? So if phi I vector will come up to MTA, then you will have the maximum torque that can be produced. Understood? So that is when you will have the maximum torque in the machine, okay, or in the relay. Now let me write down the net torque equation. So the net torque will be, as I was telling, will be equal to V into I cos theta minus tau minus K. Let us say in a given condition this value is a constant, okay, some constant K1. So at threshold condition means what? When the net torque is 0, that means all the operating torques and restraining torques are equal, and any torque above the threshold torque the relay will operate. See, it is at the verge of operation. So at threshold condition, okay, net torque will be 0. Net torque will be 0 means what does it mean? K1 VI will be equal to spring K, isn't it? So VI will be equal to K by K1. Let us say this is K double dash. This is some constant. Understood? So product of voltage and current is a constant. So if I want to draw the characteristics curve of this particular relay, it is the product characteristic, product of voltage as well as current. So voltage and current product is some constant value, means how does the curve look like? It is a rectangular hyperbola, as you know. Product characteristics are always rectangular hyperbolic characteristic. Now you see, from this characteristic of a directional relay, I can find the voltage is having certain minimum value, okay, because voltage value is not, see, throughout this curve you can't find voltage less than this value, V minimum, and you also can't find current less than this much value, I minimum. So there is one important point to be noted. There is minimum amount of voltage and minimum amount of current to be supplied so that the relay will operate. So at the verge of operation, the product of VI is K double dash. Now the relay will operate only if the now, okay, VI product will be greater than K double dash, isn't it? Because now measured VI value product should be greater than K double dash, then only operation will be there. And it will not operate, no operation, if VI product is less than K double dash, and VI product is equal to K double dash, means that is at the verge of operation, that is threshold condition. So any characteristic, okay, the region beyond this curve is called as operating zone. This is operating zone, and the region behind this curve, this is no operation zone. Understood? This is operating zone and no operating zone. Now as I was telling, the product of voltage and current should be greater than the some k double dash constant, then only the relay will operate. So that doesn't mean that you can take any value of voltage and current so that the k double dash will be the relay will be operating. The condition to be satisfied is that whatever the V and I you are getting greater than k double dash product, that V and I should be greater than V minimum and I minimum. Okay, let us say V minimum is 10 volts, I minimum is 1 ampere, and I am getting k double dash at threshold condition product will be equals to, okay, this is equal to some 20. Okay, 20 is the product, isn't it? Okay, I am getting 20. Let us say now I am measuring Vm as 5 and I measured is 4. Now tell me what is the product of this new Vi? This is, okay, let us say this is 5, 25. Now 25 is greater than 20 or not? Yes, it is greater than 20. But will this relay operate? No, it does not operate. Why? Because I is greater than minimum current 1 amp, but Vm is not greater than minimum current 10 volts. So it can operate only under this condition. Let us say if V minimum is, let us see this 20 only, no? V minimum is 50, I minimum is 5, 15 into 5 is some 75, then the relay will operate. Why? Because the voltage and current are greater than V minimum and I minimum, and the product is greater than the already set value of product. Understood? Then only the relay will operate. So there are certain conditions. Okay, there is one problem associated with this kind of directional relays. What is that? Is if fault takes place near to relay. If fault takes place near to relay, what happens to voltage at the fault? Voltage will be very less, and in many times voltage will be less than the V minimum required for the relay to operate. V minimum required for the relay to operate. Do you think if the fault occurs in this kind of situation, will the relay will operate? No, the relay will not operate. So relay, no operation. So that is one serious disadvantage associated with a directional relay. Let us say this is the transmission line and here is the relay. So if the fault occurs anywhere here or here, the voltage fed to the relay will be less than the V minimum, then the relay may not operate. But there will be certain distance after the relay up to which the voltage value will be more. Suppose voltage value will be less. If the fault occurs anywhere above this point, then the voltage value will be equal to V minimum. So that zone that zone in the zone of protection up to which the relay will not respond for any fault is called as dead zone of protection. That means if any fault takes place within this zone, okay, the voltage, suppose if fault takes place here, the voltage applied to the or available at the relay will be less than the V minimum and the relay will not operate. So this region is called as dead zone. It is a zone up to which in a distance relay the relay will not operate. Directional relay, the relay does not operate. This point is called as dead zone concept. Next aspect is, let us say under threshold condition. Under threshold condition, as we said, net torque produced will be equal to 0. Net torque is equal to 0. Let us say spring torque also equal to 0. If spring torque also equal to 0, then the value of torque V into I cos theta minus tau will be equal to 0. That means I can write, okay, this in this way. Cos theta minus tau will be equal to 0, and theta can be written as, okay, theta minus tau will be written as plus or minus pi by 2, or theta value can be written as, okay, tau plus or minus pi by 2. Okay, this particular equation is called as polar characteristic, okay, polar characteristic of directional relay. So this may be directly asked in your, okay, in your competitive exams. Which of the following equation represent or relation represents the polar characteristics of a directional relay? What does it says? This equation is showing you how much variation in theta is allowed. Let me draw the diagram, then it will be a clarity for you. So this is the voltage. Understood? This is the voltage. So voltage some angle lagging, you will have the phi V, that is the flux produced by the voltage. Now to get maximum torque, the maximum torque should be 90 degrees with the voltage flux, isn't it? This is the torque angle. Current may be somewhere in between here. Okay, so that is theta. This is the current or flux produced due to current. Now according to this equation, tau plus or minus pi by 2. So this is the tau plus or minus pi by 2. So what will be the 90 degrees to the tau? So this is 90 degrees to the tau, and this is also 90 degrees to the tau, isn't it? This region, okay, all this region, let us say I am considering the existence of spring torque also. If I am considering the existence of spring torque also, let us say this region, I am having another line like this. So this region contributes due to spring torque. So if the theta, if the current vector, if it varies up to these angles, okay, up to this line, all this zone is operating zone. So above this, all the area above this region or this line is operating, and below that is no operating. So that is the polar characteristics of a directional relay. In the next video, we will see how do we select the direction of a directional relay in a transmission line. So this is the most sought after question by many students. It was asked number of times in GATE examination and also many other examinations. Thank you.